Good morning, students. So we discussed the last class. So what is the some problems? So based on current electricity. Okay, got it. So what is the effective capacitor, effective resistance? Okay. So what is the parallel combination, series combination? So etc. We discussed in a last class. Okay, got it. So today discuss the another problem. So that is a battery. Battery of EMF 10 volts and internal resistance 3 volts is connected to a resistor capital R. If one is taken, first one is if the current in the circuit is 0.5 amps. Calculate the value of R. And also what is the terminal voltage of the battery when the circuit is closed. Okay, right. So now given problem, so very important problem. A battery of EMF means electromotive force that is called as a విద్యుత్ చాలక బలం అని పిలుస్తాం. electromotive force. Okay, that is called as a EMF is also called as a voltage. EMF is also called as a voltage. So that is called as a 10 volts. The battery 10 volts. And internal resistance say 3 ohms is connected to a resistor R. Okay, so now we are taken external resistor. So this is called as external resistor capital R, and is connected battery to internal resistor small r is taken. Voltage 10 volts. Okay, got it. 10 volts. So the I is the current passing through the circuit. So if the current in the circuit is 0.5 amps current passing through the circuit. That means now here calculate the value of R. Okay, capital R. And so what is the terminal voltage of the battery? When the circuit is closed? Okay, when the circuit is closed. Okay. Now from the circuit diagram, R is called as a external resistance. And small r is called as a internal resistance. And so this one is called as a battery of 10 volts. And so the current passing through the circuit is I is equal to 0.5 amps. Okay, got it. Right. So now given information, first of all, So that is called as a small r and capital R. So small r internal resistance is small r is equal 3 ohms. Okay, small r is equal 3 ohms. Internal resistance is small r is equal 3 ohms. Also voltage EMF is equal 10 volts. 10 volts. Okay, got it. And so the current passing through the circuit I is equal 0.5 amps. Okay. And so what is the calculate the value of the capital R. Okay. So general equation by using V is equal to I R. Okay, but in the equation, so E is equal V R E. E is means EMF. Okay, so EMF is equal I. We have taken R, but here two R. So another one taken is the external resistance, another is taken the internal resistance. That means R plus R is connected. Okay, E is equal I R plus R. Okay, got it. So E is equal R plus R. So now to find out the capital R external resistance. Okay, got it. So E is equal I. E is means that is 10 volts of the battery is connected. I is the 0.5. And R is means to find out the small r is equal 3 ohms is connected. Okay, got it. So now the 0.5 is taken outside. Okay, so 10 by 0.5 is equal R plus 3. Okay, so point is cancelled. So digit is taken above. So 520. Okay, so 20 is equal R plus 3. So R is equal to 20 minus 3 is equal 17 ohms is connected. Okay, so R value is 17 ohms in the circuit. Got it? Okay, now to find out the another problem. So what is the terminal voltage of a battery when the circuit is closed? So terminal voltage. So V is equal to IR, we can write directly. So V is equal, I is equal 0.5 into R is the external resistance is 17. Okay, so 17 into 5 is 85. So 8.5 voltage is taken. Okay, 8.5 voltage, terminal voltage. So simplification, we get another equation is also E is equal V minus IR. Okay, so that is also simplification terminal voltage. Okay, so the terminal voltage 8.5 volts and the external resistance in the circuit 17 ohms. Okay, got it. So now is taken another problem. So that is 3 resistors of each resistance is 10 ohms are connected in turns to obtain minimum resistance and maximum resistance and compute the effective resistance in each case. The ratio of minimum to maximum resistance so obtained. Okay, got it. So now here given problem. So that is the 3 resistors of each resistance is taken 10 ohms. So 3 resistors R1 is equal to R2 is equal to R3, that is equal 10 ohms resistance. Okay, given. And so obtain minimum resistance and maximum resistance. So minimum resistance, maximum resistance. What is the series combination or connected of a resistors and in a parallel combination or connected in a resistor? So series combination is taken. So that is called as a R is equal to R1 plus R2 plus R3 in series combination. And a parallel combination is called as a 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, got it. Now in the series combination, so the maximum, okay, so the maximum, so in maximum resistance are obtained in a series combination, okay, and so the minimum resistance are obtained in a parallel combination. Got it? So the minimum resistance. So the minimum resistance and maximum resistance. So the maximum resistance obtained in a series combination of the capacitor of the resistors. And so the maximum resistance is obtained in a series combination. Minimum resistance are obtained in a parallel combination. Okay. So this is called as a maximum resistance in a series combination. Minimum resistance in a parallel combination. Now, so the capacitors are connected, that is mean the resistors are connected. So 3 resistors. So each one resistance is 10 ohms are connected in a series combination and connected in a parallel combination. So connected in a series combination, first of all, series combination. So R is equal to R1 plus R2 plus R3. So R is equal, R1 is means 10 ohms plus 10 ohms plus 10 ohms. That is equal to 30 ohms is a maximum. Okay, got it. Next, in parallel combination. In parallel combination, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is equal 1 by R is equal 1 by 10 plus 1 by 10 plus 1 by 10 are connected in a parallel combination. So that is called as a 3 by 10. Okay. So 1 by R is equal 3 by 10. R is equal 10 by 3. So this is called as a minimum. Okay. So minimum resistance. Now here, so the effective resistance in each case. So this is called as a effective resistance and in a series combination, effective resistance in a parallel combination. And so the ratio to minimum to maximum resistance. So minimum to maximum resistance means RP parallel. Okay. So series is taken RS. So parallel by series. So 10 by 3 by 30. Okay, so 10 by 90 is equal 0 cancel. So 1:9 ratio is taken. Okay, RP is to RS is equal 1:9 ratio. Okay, got it. So now discuss the another important topic. So that is the potentiometer. So what is the potentiometer? What is the principle of potentiometer? And so now comparing of the EMF of two cells by using a potentiometer, and also to find out the internal resistance of the given two cells. Okay, got it. So primary cells, comparing of the EMF of the two cells and to find out the internal resistance of the given two cells. So what is the potentiometer? What is the potentiometer? So potentiometer is based on the principle of. So potentiometer is based on the principle of that when a steady current flowing through the wire and so uniform area of cross section, and so the potential difference across any portion on the wire, potential difference across any points on the wire, any portion on the wire is directly proportional its length of the wire. Is directly proportional its length of the wire. So we can write in mathematical form E is directly proportional L. Okay, got it? E is directly proportional L. That means the potentiometer is based on the principle that when a current is passing through the circuit, steady current, and so uniform area of cross section of the wire. Okay, so the potential difference any points on the wire, potential difference any points on the wire is directly proportional its length. Okay, E is directly proportional L, we can write in mathematical form. Got it? So now comparing of the EMF of the two cells, comparing of the EMF of the two cells by using the potentiometer, So comparing of EMF of the two cells, so the circuit diagram is taken. Okay, got it. So the potentiometer wire, the circuit diagram is seen on board. Okay, so in the circuit diagram, this is called as a potentiometer wire. So the potentiometer wire, the current flowing on potentiometer wire is steady current and uniform area of cross section. Uniform area of cross section. Okay, and so here in the circuit diagram. So this is called as a comparing of the EMF of two cells are introduced in the circuit. Comparing of the two given cells E1 and E2 are introduced in the circuit. And so this is called as a two-way key. Two-way key. What is the two-way key? ఒక స్విచ్ ఆఫ్ ఉండి ఇంకొకటి ఆన్ ఉంటే మాత్రమే బల్బ్ వస్తుంది. ఒకటి ఆన్ ఉండి ఇంకొకటి ఆఫ్ ఉంటే మాత్రమే మనకు బల్బ్ అనేది ఆన్లో ఉంటుంది. దట్ మీన్స్ ఏంటంటే టూ ఆఫ్ ఉన్నా టూ ఆన్ ఉన్నా బల్బ్ వెలిగదు. దట్ ఈస్ కాల్డ్ as a two-way key. Two-way key. So this is called as a galvanometer. Okay, galvanometer. And so here attached through wire through a jockey. Okay, jockey is connected through a wire. And so this is called as a battery. And this is called as a rheostat. So what is the main purpose of the rheostat? So the steady current flowing through a circuit. Okay, so the current is drawn from a battery. The current is drawn from a battery, but the steady current is flowing through a circuit by using the rheostat. Okay, got it, rheostat. So what is the main purpose of the rheostat? The steady current is flowing through a circuit by using the rheostat. And so the plug key is used, that is called as a just like switch. Okay, switch. Right. So this is called as a E1 and E2 are comparing of the E2 cells are in the circuit is taken. And so that is called as a two-way key and the galvanometer. So the galvanometer used to show the deflection. Show the deflection. Deflection means apavartanam chupistundi. Okay na? Is show the deflection. And so the galvanum, that is the jockey, is connected to a galvanometer, okay, in the circuit. Got it? And so here a rheostat and the battery is connected. Here, so for primary connections are in the circuit is taken. So the negative terminals of the battery is connected to negative terminals of the battery is connected to two-way key, two keys. Two-way key, two keys. And so the common key. Okay, 3 is a common key. So the common key is connected jockey through a galvanometer. So galvanometer means the main purpose of the show the deflections. Okay, show the deflections. That is called as a small current is passing. So through that is means the deflection is arranged. Okay, so now he is given. This is called as a potentiometer wire. So the potentiometer wire is placed. Okay, is placed on the wooden board. Okay, so the potentiometer wire is placed on the wooden board. Okay, got it. So the rheostat is connected. So main purpose of the rheostat, the steady current flowing through the circuit. So the battery is connected and key is called as a plug key. Just the circuit, the connections are completed. The key is placed. That is means the plug key. This is called as a plug key. Okay, plug key. And so this is called as a batteries. Okay, EMF of cells. That is the cells E1 cell and E2 cells. Okay, and so 1, 2, 3 are this called as a two-way key. Okay, so 1 and 2 and 3. This is called as the 3 keys. 3 keys. 1, 2, 3. 3 keys. So key is introduced in the circuit. Key is introduced in the circuit. So the circuit is a closed current passing. Okay, got it. So this is called as a key. So the key is introduced between the plates. Okay, so that is called as a closed circuit. The current is passing. So the key is removed from the circuit. Okay, so that is does not current flowing through the circuit. Okay, got it. So the 1, 2, 3 is called as the two-way key. So the two-way key. So the third key is the common key. So the common key is connected to a jockey. So jockey means it's a sharp edge device. Sharp edge device. So వైర్ పైన మనం జాకీని మూవ్ చేసుకుంటూ వెళ్తాం. ఓకేనా? సో ఈ జాకీ పైన అంటే ఈ జాకీని ఈ వైర్ పైన మూవ్ చేసుకుంటూ వెళ్తాం, లేకపోతే టచ్ చేసుకుంటూ వెళ్తాం. ఓకే, గోట్ ఇట్. Now, so primary circuit or connections is taken. So the battery, okay, so the battery is negative, is connected, battery is a positive. A battery negative or positive. So it is connected to the, so the positive terminals of the cells and the negative terminals of the two cells are connected to 1, 2 key and the third key is connected to a jockey through a galvanometer. So this is called as a primary connections. Primary connections. Okay, all connections are made up, or all connections are set up. So the key is a closed. Key is a closed. Okay, got it. So the current passing through the circuit. Now, first step is taken. Okay, so the first step is taken here. So the K is closed, the current passing through the circuit. So 1 and 3 keys are put in the circuit. 1 and 3 keys are put in circuit. First step. Okay, so the 2 key is removed. Only 1 and 3 keys, 2 keys are inserted in the two-way box. Okay, got it. So first of all, 1 and 3. These 2 keys are introduced in the circuit. 2 keys removed. 1 and 3 keys introduced in the circuit. So that means only the E1 primary cell or E1 cell is introduced in the circuit. Okay, got it. Only first step. 1 and 3 keys are okay involved, or that is called as the insert in a two-way box. Okay, so that means only E1 cell is including in a circuit. E1 cell is only including or introduced in the circuit. Okay, so that means only E1 cell is introduced in the circuit. E2 cell is just like switch off. E2 cell is just like switch off mode. Only E1 cell is active. Okay, got it? Why? So because the 2 key is removed, only the insert key 1 and 3. So the galvanometer and the jockey. So the jockey is touching on the wire. Okay, on the red box. So the jockey is moved on the circuit, on the wire. Okay, of wooden box. So the wire is touched on the wire. There is until there is no deflection on the galvanometer. No deflection in the galvanometer. Okay, got it. So very important point. So the jockey is moved on the potentiometer wire. The jockey is moved on the potentiometer wire until the galvanometer shows no deflection. No deflection. No deflection. అంటే అపవర్తనం. డిఫ్లెక్షన్ మీన్స్ అపవర్తనం, కదలనంత వరకు మనం తీసుకోవచ్చు. ఓకేనా? సో దట్ మీన్స్ ఓకే అంటే మనకు జాకీలో జీరో చూపెట్టాలి. ఓకేనా? సో దట్ మీన్స్ జీరో చూపెట్టాలి, జీరో ఇండికేట్ చేయాలి. సో జాకీ ఈస్ మూవ్డ్ ఆన్ ది పొటెన్షియోమీటర్ వైర్ అంటిల్ ది గాల్వానోమీటర్ షో ది నో డిఫ్లెక్షన్. డిఫ్లెక్షన్ జరగనంత వరకు మనం ఆ వైర్ పైన జాకీని మూవ్ చేసుకుంటూ వెళ్ళచ్చు. ఓకేనా? ఎక్కడైతే చూపిస్తుందో అక్కడ స్టాప్ చేయాలి. స్టాప్ చేసేసి సో అక్కడ ప్రైమరీ సెల్ దట్ ఈస్ ద E1 ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ L1. సో దిస్ ఇస్ కాల్డ్ యాజ్ ఏ L1. L1 మీన్స్ లెంత్. So the length to measure by using the scale. Scale also introduced on the board, including on the board. Okay, the scale is also including on the board. So the scale to measure the 30 centimeters or 40 centimeters or 60 centimeters. So that is called means. So the E1 is directly proportional L1. E1 is directly proportional L1. And also similar pattern here also like that. So that is so the two plug keys is removed in a two-way box. So here 1 and 3. These are two keys are removed from the circuit. Only the 2 and 3 keys are introduced or inserted in the circuit. One is keys removed. 2 and 3 keys are inserted in a two-way box. Okay, so that way only the E1 cell is switched off, only E2 cell is there working. Okay, so that means the galvanometer so once again repeated so moved on a potentiometer wire so that till the zero deflections, the no deflections up to find out the length L2. So that is called as a E2 is directly proportional L2. E1 is directly proportional L1 and also E2 is directly proportional L2. Okay, so the galvanometer, that is means the jockey is moved on a potentiometer wire till okay, so that no deflection on the galvanometer. So that point is called as the E2 is direct proportional L2. So comparing of the equation 1 and equation 2, so E1 by E2 is equal L1 by L2. So this is called as a, by using of the comparing of the EMF of the two cells by using the galvanometer. Comparing of the EMF of two cells by using the galvanometer. So E1 by E2 is equal L1 by L2. Okay, got it. So further class we discuss about the what is the potentiometer and so to find out the internal resistance of the resistance box. Okay, right. Thank you, students.